So now we're basically ready to run the code with respect to the GRU model. And first we need to import a few things. Just as we did before, sequential import layers, and we're gonna use RMS prop as the optimizer. All right, so let's now start building our model. I'm gonna paste this block of code here, so sequential model still. And here we're gonna add the layers. And GRU, we need to give two arguments. First one is 32. Now 32 is the number of units or the dimension of the output space if you look into the Keras documentation. It doesn't tell you a lot, but basically this 32 is the dimension of your hidden state. And I've explained this in the brief about this coding session. And then you have the input shape. Yeah, and the input shape is nothing more than the shape of the features matrix or vector. Yeah. Then, of course, at the end, we have a dense layer. And compiling the model, we use RMS prop. And as a loss, this is not a classification problem. We use the mean absolute error. And then, of course, we're going to do the model fit. Steps per epoch 500, 20 epochs, and we're going to use the validation data to validate the model. So here, this float data shape, -1 means that you take columns, and the shape, of course, of float data columns is 40. All right. So let's now run this code. It will take a little while. Here we go. We're just started. All right, we're done 20 epochs, and now let's see if we can print the results. The block of code here we've used numerous times, so I'm not going to explain it. So let's run this. And here is the outcome. Yeah. Basically, what we see here is that we start overfitting almost, immediately. Yeah. So we start overfitting from epoch 5 onwards. So we will need to have a solution for that. And remember, there's a few solutions for neural nets. One was called dropout. Here, dropout we can use, but we need to use recurrent dropout. And it's slightly different from traditional dropout. So